The Hubble Space Telescope has been in space for over 33 years, and it has been incredibly successful. Even though it wasn't originally designed to study objects in our solar system, it has done so during its mission, capturing amazing moments we might have otherwise missed. Not every planet has its own dedicated mission, and there's much more to see in our solar system beyond planets. Let's take a journey through the solar system, exploring some objects Hubble has observed. I'm Alex McColgan, and you're watching Astrum. In this episode of the Hubble Images series, we'll look at snapshots of our solar system taken by Hubble and explain their significance. We'll begin our tour close to home with our nearest neighbor, the Moon. The Moon appears very large in our sky, so Hubble can't capture its whole surface in one shot. Besides, other missions, like NASA's Lunar Reconnaissance Orbiter, take better pictures of the Moon, so Hubble focuses on other targets. However, in 2012, Hubble took an image of the Moon while Venus was passing in front of the Sun. Why? Scientists used the Moon as a giant mirror to study small changes caused by sunlight passing through Venus's atmosphere. This helped determine its chemical composition. Since we already know Venus's atmosphere, this was a test to see if this technique works accurately. Hubble often uses a similar method to study distant planets when they pass in front of stars, but since the Sun is too bright, the Moon provided a reflection for this experiment. Hubble may struggle with the Moon, but it does better with Mars. Hubble has taken many images of Mars, showing the planet's full surface, which orbiting spacecraft can't always do. These images reveal dust storms, seasonal changes, and weather, helping scientists study the planet and plan for rovers. One time-lapse even showed a planet-wide dust storm, with Mars's tiny moons, Phobos and Deimos, racing around in the background. Phobos orbits Mars in just 7.5 hours, faster than a Martian day. Beyond Mars, we reach the asteroid belt before the first gas giant, Jupiter. The asteroid belt is filled with interesting objects. One such object is asteroid 6478 Gault, which looks like a comet with two tails. This happens because sunlight's radiation pushes on the asteroid, causing it to spin faster. Its rotation now happens every 2 hours, which is so fast that loose material is flung into space. Over time, the asteroid will break apart, as most asteroids are like rubble piles rather than solid rocks. Another example is P/2010A2, which looks like a comet but is actually the result of two asteroids colliding. The collision created a strange X-shaped structure as debris was flung into space and slowly pulled back by weak gravity. Some fragments escaped entirely. If objects in the asteroid belt stray too far from their stable paths, they risk encountering Jupiter's massive gravity. Jupiter is so large that it makes up about 3/4 of the solar system's mass, excluding the Sun. Its gravity acts like a vacuum, pulling in nearby objects. This was seen in 1994 when the comet Shoemaker-Levy 9 came too close. Jupiter's gravity broke it apart, and its fragments crashed into the planet at incredible speeds, creating explosions as hot as 23,000 degrees Celsius. The largest impact left a dark spot the size of Earth and released energy equal to 6 million megatons of TNT. Jupiter doesn't just capture objects, it also displays stunning auroras. While Earth has auroras, Jupiter's are much brighter and more powerful, glowing in ultraviolet light. In 2016, Hubble observed Jupiter's auroras, while the Juno spacecraft measured solar wind heading toward the planet. Unlike Earth's auroras, which depend on solar storms, Jupiter's auroras are powered mainly by charged particles in its radiation belt. These auroras are so strong they never stop. Finally, one of Jupiter's moons, Europa, is especially fascinating. Europa could be home to life, making it one of the most exciting places in the solar system. Hubble has captured detailed images of Europa, even from great distances, giving us clues about its icy surface and the ocean beneath. The Moon. The huge apparent size of the Moon in our sky is a significant challenge for the Hubble telescope. Unlike other space objects, the huge surface area of the lunar satellite cannot be framed in one shot. Thus, other space missions, especially the Lunar Reconnaissance Orbiter from NASA, have been more capable of capturing the huge surface area of the Moon. Because of these reasons, the resources of Hubble are spent more valuably on other astronomical objects. But in 2012, it managed to take a very interesting picture during one of the rare alignments of Earth, Venus, and the Sun when Venus passed across the face of our solar companion. This rare configuration allowed scientists, for the first time, to take advantage of the Moon as a giant mirror. Using the Moon as a reflector, researchers were able to detect subtle changes in light scattering patterns through the atmosphere of Venus. These minute changes showed previously unknown details about the planet's gaseous envelope despite its composition already being well documented. This experiment was an important test case for the accuracy of the light scattering method for analyzing exoplanet atmospheres. Hubble has been using this technique frequently, studying the atmospheres of worlds beyond our solar system when they transit across their parent stars. Our Sun is too luminous and would overpower the sensors on the telescope during such observations. The Moon's reflective surface proved invaluable in allowing scientists to collect the data they needed. The Hubble spacecraft could hardly capture the whole of the lunar surface due to severe technical difficulties. In dramatic contrast, Mars is a much more approachable object for observation. Its red ground can be fully mapped through Hubble's imaging. Such mapping provides insights into Martian weather, geological processes, and habitability. Time-lapse sequences taken by Hubble provide fascinating insights into the red planet's dynamic environment. One dramatic example shows a global dust storm swallowing the entire planet, hiding even the tiniest details of the surface. Against the bright orange clouds swirling around, Mars' small moons, Phobos and Deimos, can be seen hurtling quickly around their parent world. This is most evident in longer exposure sequences, where their rapid motion discloses the singular orbital properties that distinguish these small satellites from other objects. Of the two natural satellites of Mars, the larger and closer to the planet is Phobos, which exhibits a very peculiar orbit. This little moon orbits the planet in only 7.5 hours, making it the only satellite in our solar system that orbits its host body faster than the host body's rotational period. To put this in perspective, a time-lapse centered on Phobos demonstrates its motion over just 22 minutes, revealing the Moon's incredibly fast speed as it whips through space close to its parent planet. As we go farther in our journey through space, crossing over the inner planets, comes the first of the gas giants, Jupiter. But before arriving at that massive world, there is another prominent feature of our solar system, the asteroid belt. Within this vast area between Mars and Jupiter, countless small rocky bodies fill the space, the leftover material from the dawn of the formation of the planets. These ancient relics provide vital insight into the history and evolution of our celestial neighborhood. Now that we've taken a closer look at our Moon, let's venture further into the solar system, where mysteries continue to unfold. Beyond Mars lies a region full of ancient relics that hold the keys to understanding the early days of our solar system. But don't be fooled. What we find in the asteroid belt may be just as surprising as any of the distant worlds we've encountered. Get ready, because Hubble's next target is an asteroid unlike any other. The asteroid belt. The asteroid belt is an interesting region filled with objects of various kinds. Many opportunities present themselves for scientific studies, one of which is the curious asteroid 6478 Gault, a mislabeled heavenly body that has now captured Hubble's attention. You may be surprised to discover that this object, with twin tails like a comet, is actually an asteroid and has been named Gault. This extraterrestrial creature inhabits the asteroid belt and was imaged in 2019. So why does it have a tail? According to scientists, the answer lies in a phenomenon called the YORP effect. Solar radiation exerts a small but steady force on irregularly shaped bodies, and under the right conditions, this can gradually increase their rotation speed. In Gault's case, its 3.5 kilometers wide body has been spinning faster over time and now completes one rotation every 2 hours. The upper limit of what an asteroid can endure, this rapid rotation generates centrifugal forces stronger than the asteroid's gravity, which causes loose material to be ejected into space. Those ejected particles form the tails, and Gault will most likely disintegrate entirely over time. Like many other asteroids and comets, Gault is not a monolithic rock but a fragile rubble pile held together by weak gravitational forces. Such a structure is especially susceptible to the effects of solar radiation and collisions. The asteroid belt, a region of chaotic population with 1 to 2 million asteroids larger than a kilometer and uncountable smaller ones, is a dynamic region. To illustrate this complexity, Let's look at P/2010A2. It appears at first to be a fairly typical comet, but it has been discovered that its nucleus is unlike any other seen before. The filamentary structure is clearly not normal. Incredibly, this is not a nucleus of a comet. It's not even a comet. What we are seeing here is a truly rare occurrence, an asteroid collision. The X-shaped structure near the nucleus comprises debris from the impact, with rubble being ejected in 4 directions. Some of this material is pulled back toward the center of mass by the faint gravitational pull, while particles in the tail have escaped completely. This collision shows how chaotic the asteroid belt is. In spite of all that chaos, most of the asteroids in this region move in relatively stable, circular orbits around the Sun. If it wanders too far from such a path as comets do, it's likely to encounter a much stronger gravitational force. This thin line between stability and instability makes the asteroid belt so interesting for astronomical study. Surface through the plumes and have been deposited there. The possibility of sea salt on Europa is quite tantalizing and would, if true, indicate that hydrothermal activity occurs on the ocean floor just like on the Earth. Hydrothermal springs underwater, also called vents, are hotbeds of organisms, making it a potentially rewarding avenue of search and research. However, the prospect of a submarine mission to probe Europa's ocean remains distant, at best, several decades away. As we continue our journey through the outer planets, we find ourselves at the threshold of yet another fascinating world ripe for scientific inquiry and discovery. Saturn. By 2017, Saturn had remained unexplored by dedicated spacecraft, with the Hubble Space Telescope serving as our primary instrument for studying this gas giant. Hubble frequently observes Saturn, monitoring phenomena such as atmospheric conditions and seasonal fluctuations. Cassini's exploration lasted only half a Saturnian year, so Hubble now plays a crucial role in filling data gaps. Among the most dramatic and striking events Hubble has viewed are gigantic storms measuring thousands of kilometers across Saturn's disk. But the telescope does more than produce scientific breakthroughs on the Saturnian system. It can reveal beauty. Here are a few of the best images taken so far. In our final stops on this virtual tour, let us first visit the first of the icy giants. Beyond Saturn, we encounter a planet that challenges everything we know about the solar system, Uranus, with its tilted axis and strange magnetic field. Let's dive into what makes this icy giant so fascinating. Uranus. While Jupiter and Neptune present interesting phenomena in their atmospheres, Uranus has to offer a variety of interesting features that distinguish it from other planets. Among them, the most mysterious one is its magnetic field, where the spectacle of auroras near its polar regions competes with Jupiter's more famous storm systems. Curiously, the magnetic poles of Uranus are not aligned with its rotational axis, which is a very curious state of affairs that makes it even more mysterious. What makes this weirdness even weirder is that Uranus's rotational axis is tilted extremely, leading it to almost roll perpetually in its orbit. This strange tilt also drastically affects the patterns of solar eclipses for Uranus and makes them rare events. The first recorded passage of a moon's shadow across Uranus occurred in 2006 and was quite an event in astronomical observation. Previously, the last alignment occurred in 1965, when telescopes with the capability to observe such faraway celestial events were not developed. The historic observation provided stunning pictures of aerial shadows transiting across the surface of Uranus, courtesy of NASA's Hubble Space Telescope, offering new insights into the composition of the planet's atmosphere. Continued observations from Hubble have since that groundbreaking moment revealed seasonal changes in Uranus's atmosphere over various stages of its 84-year orbit. When one pole of Uranus tilts towards the Sun, its atmosphere changes and forms a large cloud cap during that summer, rare phenomenon in our solar system. It is important to note that with Hubble, only less than half of a complete Uranian year has been observed because it's a relatively young age of 34 years. Consequently, much remains to be discovered about the seasonal dynamics and atmospheric behavior of this planet. As scientists continue to study this enigmatic world, they may still come up with more secrets lying beneath its peculiar tilt and atmospheric quirks. Hippocamp. Last but not least, Hubble made the most important discovery. The smallest known moon of Neptune, baptized as Hippocamp. This small object is a pretty interesting topic for further investigation. It will bring important knowledge about the beginning and development processes of small moons in the solar system.